Alright, number 10 says suppose the greatest common divisor of A, B, and C is 1. Is it necessarily true that greatest common divisor of A and B equals the greatest common divisor of B and C, which is 1? No, that's not going to be true. We did work a problem earlier that had 3 numbers. The greatest common divisor between 2 of them was 3, but the third one was 1. Number 11, is it true that every common divisor of 2 non-zero whole numbers, A and B, is a divisor of the greatest common divisor of A and B? Yes, I do believe this statement is true. I can show you a small example, but we'll pick the correct explanation. So let's just again say 4 and 8. Let me write it like this. 4 and 8 factors are 1, 2, and 4. 8 are 1, 2, 4, and 8. Okay. They have in common 2, 4, and 1. 4 would be the GCD. 4 is divisible by 2, which is a common factor, and by 1. So that's just one small example. But let's look at this and see why. So if we're saying yes, it's true that every common multiple of 2 non-digit whole numbers, A and B, is a multiple of the GCD AB by definition. And then yes, it is true that every common divisor of 2 non-zero whole numbers, A and B, is a divisor of GCD by definition of GCD. Okay, so both of them say is a divisor. I think it's that's the definition of GCD. And then 12, it says explain why the greatest common divisor of A and B is always a divisor of the least common multiple. So let's look at the options. Each prime factorization of the greatest common divisor is raised to a greater exponent than that prime in the prime factorization of the LCM. That would be backwards. Each prime in the prime factorization of the greatest common divisor is raised to a lesser or equal to exponent than the prime in the prime factorization of the LCM. That is true. Each prime in the prime factorization of the greatest common divisor is raised to an equal exponent than that in the prime of that. So not necessarily true. Could be equal. And then D says each prime in the prime factorization of the greatest common divisor is raised to a lesser exponent than that in the prime of the prime factorization. B is going to be the correct one. It could be less than or equal to, depending on what they have in common. Just for example, I'll show you with some numbers. Let's say we're looking at 8 and 24. Prime factorization of 8 is 2 to the third. Okay. 24 can be broken down to 8 times 3, which is 2 to the third times 3. What they have in common is a 2 to the third. So it could be equal. It also could be less than if this was a smaller number. So B is going to be the best explanation that's according to the definition.